Hello everybody, welcome to my class on geometric distribution. So before you have already done the binomial distribution where you saw there were probability of success as well as the probability of failure only out of n number of trials, where n was finitely large number. And also you have seen that the number of successes S, or you abbreviated that successes by R. So number of successes were countable. But here in geometric distribution, there is a bit different story. A bit different story means it's not that much far away from the binomial distribution, although, but this is also a case of Bernoulli distribution. So, for example, you can consider a situation in which we are attempting to roll a 6 with an ordinary fair die, for example. Then how likely are we to get our first 6 on the first roll, or on the second roll, or on the third roll, and so on. So in that case, we answer the questions using the constant probability of success and failure, and that comes under the geometric distribution. And obviously Q is 1 minus P, which is the probability of failure. All right, so let's consider a situation of a tree diagram like this. So it is probability of success as P. If this is not success, then this is Q. So for example, you are intended to get a 6 in the rolling of a fair cubical dice, for example. So in that case, say probability of success as you obtained 6, so that is 1 by 6, and the probability of failure in this case is 1 minus 1 by 6, that is 5 by 6. All right, so I'm taking one example of the cube of the throwing of cubical dice. So in that case, for example, if you obtained 6, then you stop your work. All right, so you have got success at first trial is P. Now for example, your first trial is failed, that means this is the probability of Q, that is 5 by 6. Then you will make another trial and you got another 6, for example. So in that case, you can say that Px equals to 2, that means success at the second attempt. So it is in the first attempt it is failed, so that is Q, and then it is success in the second attempt, so you can write Q times of P. Similarly, for example, if you write Px equals to 3, that means what? Px equals to 3 means it means in fact actually success at third trial. Here in this case, the success at second trial, this is the success at the first trial. And then in that case, it means you have got success on third trial. That means first failure, second failure, and then third success. So here you can see that first failure, second failure, and then success, and then it will be Q square times P. And if x starts from 1, so we put here x equals to 1, 2, 3, and it keeps on going up to infinity. So it is indefinitely x is in fact it is indefinitely large mathematically. So here in this case, just now we have seen that. So if you put the range of value of x, so x starts to run from 1 and it goes towards infinity. And then let's expand it. First of all, this is summation unless otherwise stated. Here it is understood that x goes from 1 to infinity. So now here in this case, summation means what you can write is that this is the probability function of the geometric distribution now. So you can write here Q x minus 1 and then P. P means this sort of P. Okay. So P is the constant probability. There is only one value, that is the value of success is only one. So you can take this outside, and then inside the bracket you can write here Q x minus 1. Now put 1 2 3 x equal to 1 2 3 successively. In that case you will have P times in the bracket Q to the power. If you put x equal to 1, it's going to be 0. Then plus x equals to 2. If you put x equal to 2, then it's going to be q to the power 2 minus 1 is 1, and then plus q to the power x equal to 3, then 3 minus 1 is 2, and then it is q3, and so on like this. Use the sum of numbers in an infinite geometric series where common ratio is less than 1. So S infinity, you know that this is first term divided by 1 minus R, where absolute value of R is less than 1. So if you apply this formula, so P is already here, and then for A, first term is q to the power 0, that means it is 1. So you can write here 1, and 1 minus R means 1 minus R means here you can see here this is q, and then q second term divided by first term, that is 1 is q. Also q squared by q is q. Q to the power 3 by q squared is q. So common ratio in this case is q, and you know that q is a probability of failure, and probability value is not more than 1. So that means it is always less than 1. So this formula is appropriate in this situation. And then you can see that this is P value already here, and then 1 by 1 minus q means 1 minus q is also, it is P. So this is P, and these two are cancelled out, so you are left with 1. So since total probability is 1, therefore you can say that x is an RV. That means x is the random variable in this case. You saw that the probability mass function, or you can say that the probability function for this geometric distribution is, if px equal to x, then you have q to the power x minus 1 and times p. In order to say x is the random variable, the total probability p x equals to x must be 1. And also it is found that expectation of x is 1 by p. That means we are talking of mean of geometric distribution is 1 by p, and variance of this geometric distribution is found to be variance of x equals to q by p square. All right, so this sort of thing, in fact the proofs are not required at this time, but for your understanding I'll do the proof also within this class. Okay, so this is the introduction about geometric distribution. All right, follows the random variable x follows geometric distribution with parameter p, and its probability function is given by x equals to a small x, or you can, in some book you can see that it is written r or otherwise also, but it doesn't matter. This is the first success at the xth try. So here in this case you can write here q to the power x minus 1 and times p, provided that the total probability is 1. All right, and mean of this distribution is, in fact this is expectation of x, and that is given by 1 by p, and variance of this distribution is variance of x equals to, it is found as q by p square. All right, so this is the introduction about geometric distribution. Let's see an example that makes use of geometric distribution. So here in this example the example states that the probability that Mike is shown a yellow card in any football match that he plays is half. That means the probability that Mike is shown a yellow card in any football match that he plays is half. Find the probability that Mike is next shown a yellow card in the third match that he plays. So it is asking you to find in question number A and 1, it is asking you to find P x equals to 3. That means Mike is getting yellow card at the third match, in the third match. Okay, so equals to what? So in this case, you can see that the probability that Mike will get yellow card is 1 by 2. So obviously Q value is here 1 minus P, that is 1 minus half is 1 by 2 again. And then we know that P x equals to Q to the power x minus 1, and then P. So here in this case you can see, so therefore you can say that P x equals to 3 means replace x by 3 and P and replace the values for P and Q. So here it is 1 by 2 to the power 3 minus 1, and times it is 1 by 2 because P is 1 by 2. So altogether this is 1 by 2 square. So this is 1 by 2 square and times 1 by 2. So that it is 1 by 2 square. That means 1 by 2 times 2, and then times it is 1 by 2. So 2 to the 4 to the 8. So this probability is 1. Before the fourth match that is he plays, that means it is asking you to find Px is less than 4 before the fourth match. That means before the fourth match there must be first match, second match, and third match. All right, so if you like, you can also first write Px is less or equals to 3, and then we proceed from here again. So it is just by using this formula now, Q x minus 1 times P. So it is Q, P both are half, so it is 1 by 2, and this is for 1 if you are talking of, then it is 1 minus 1 is 0, so its power is 0, and then plus 1 by 2 if you are talking of 2, so this is 2 minus 1 is 1 itself, and then the value of P is 1 by 2. Okay, so I think we forgot to mention the value of P over here, so this is also 1 by 2. So if you are trying for B, that means you know that Ex equals to 1 by P, and P value is 1 by, this is 1, so 1 by P value is half we have, so it is 1 divided by 1 by 2. So average number of yellow card that Mike can get in the match is 2. And also if you like to find the variance of X in this case, so you know that the formula for variance is Q by P square. Q value is half, and also P value is half, so it is 1 by 2 square, and then you have it is 1 by 2, and then 2 goes up, so 2 to the 4 will be upside by 1. So this is 1 by 2, and then 1 by 4 it goes up, then it is 4, and then variance is also in this case is 2 to the 4. So in order to find the standard deviation, what you can do actually, standard deviation is the variance of X. So just take the square root of 2, and that will be the standard deviation for the geometric. So let's try in question number A 2. Our P value is 1 by 2, and then Q value is again 1 minus, this is 1 by 2, so 1 minus 1 by 2 is 1 by 2. and then it is asking you to find probability that the success before fourth match mic plays, right? So here in this case, you can see that that means it is px is less than 4. It is equals to what? And also you can write that here. If you like, you can write here 1 minus px is greater equals to 4. Okay, or that is equals to 1 minus px is greater equal to 4 means px is greater than 3. So if you put 1 minus q to the power 3, for example, then it is found that 1 minus q value is 1 by 2 to the power q, and then it is 1 minus 1 by 2 to the 4 to the 8. So it is 8 minus 1, it is 7 by 8. So you have the same answer this way also, 0.875. Okay, so you can do by this method also. And what we deduce from this sort of formula is that you can see that we have used px bigger than 3 equals to q to the power 3. That means q in this case is 1 minus half, that is half. So therefore, in general, you can also note that px bigger than r, for example, is equals to q to the power r, and this is highly useful result while dealing with the geometric distribution. Let's now talk about mode of geometric distribution. So let x be the random variable that indicates number of success at xth trial. Then you can see that the random variable x can take value success at first trial, success at second trial, at third trial, at fourth trial, fifth trial, and it goes like this unending. All right, and if you like, you can write px equals to x, and for example, you take an example of rolling of a die. So probability of 6, for example, is 1 by 6. So you can say that probability of x equals to probability of this first success as 6 as 1 by 6. So therefore you can take p value is 1 by 6. So obviously its q value is going to be 1 minus 1 by 6, that is 5 by 6. So here in this case, at the first success, and also you have to keep into mind the formula q to the power x minus 1 and times p. So for example, if I am taking p equal to 1 by 6 and q equals to 5 by 6, so this is the position for p only. So success at the first trial is p, that means it is 1 by 6, and at second trial means first trial is failed, so this is 5 by 6. Then it is success at the second trial, so it is 1 by 6, and similarly success at the third trial means there have been 2 failed probability, so 5 by 6, 5 by 6, and then this is 1 by 6, and similarly for 4 you can write 5 by 6 to the power cube, and then 1 by 6, and similarly for the other events at which it happens success at that number of trial. Okay, so let's see that these values, what happens. The probability is highest at the first success, but at the second success the probability is lower than the first. At the third, the probability value is lower than the previous, and similarly at the fourth, the probability value is lower than the success at the third trial. So in this case, you can see that at the first trial the probability is highest. All right. So highest probability corresponds to mode. So therefore, mode of this distribution, this the geometric distribution is always 1. You might be interested to see how mean of geometric distribution is 1 by p and variance of this distribution is q by p square. So if you are interested, you can have a look over here. So this is proof of mean, that is expectation of x is 1 by p, and the variance bx, that is q by p square for x follows geometric distribution with parametric value p, where you can see that p is the probability of success, that is the constant probability of success, and the probability function is q x minus 1 p, where x is 1, 2, 3, and it goes on and on. X is random variable provided the total probability is 1 in this case. So let's see that expectation of x, the general formula for expectation of x is summation of x px, but here the range of values of x starts from 1 and goes towards infinity in this case. So note that in binomial distribution it starts from 0, but here in geometric distribution it starts from 1. Now just put this probability value, probability function value here. So we have term like this, and as p is constant, we take it out here. So remaining term is like this, and if you expand it, just first put 1, then it is 1 times of q, 1 minus 1 is 0, so q to the power 0 is 1, and then second time you put 2, so this is in place of 2, you can put here 2, and 2 times 1 is q to the power 1, and therefore this is 2q. All right. And similar thing you can do up to 2 more steps or 2 or 3 more steps, and it as it keeps on going, so you just put dotted line over here. Now this is the case of sequential series, the idea that we apply there. So the same idea we apply here also, because this is a geometric sequence. So what we are doing here in the along the both side, we are multiplying by q over here. So we multiply ex by q, that means we are multiplying ex equal to this term by q. So p is outside already, so q times 1 is q plus 2q square. How it is? 2 times of q, 2 times of q times q is 2q square. Similarly, these two terms are there. Now we deduct ex, qex from ex. All right. And then we have this sort of thing. You can pause it here, and then you can work out yourself to see whether or not you are getting this sort of series. Now again use this formula, s infinity equal to a by 1 minus r, and you know that the common ratio is q, which is less than 1. Okay, and therefore it is 1 by 1 minus q, because first term is 1 and the common ratio is q. You can see here, because second term divided by first term is q over here, and q is less than 1, so we can apply this formula of infinite series. So here 1 by 1 minus q, 1 minus q itself is p, and then you cancel out the p from numerator denominator. You have 1 here. Now here take out ex is taken out common, and then 1 minus q is transposed to the other side, so it is 1 by 1 minus q, and 1 by 1 minus q means it is 1 minus q is already p, so here it should be 1. So here in this case you can see that this is 1 by p. Therefore you can say that expectation of x is 1 by p. Now there is little bit of twist while getting result for the variance of the geometric distribution. So in general, you know that variance is expectation of x square minus expectation of x whole square, and you know that expectation, first of all we find expectation of x square, so it is x squared px, that we have already done in chapter 4 in probability distribution. And now take out the constant probability out of this summation, and then our term is like this. Now we work for x squared times q x to the power q to the power x minus 1. So we have to remember some standard term, that summation of qx equal to 1 by 1 minus q, and also here you can see that. Yes, here in this case, here 1 plus q square means this is summation of q, and that is found as 1 minus p over here. So the same thing you can start from here, that 1 by 1 minus q equals to summation of qx. Otherwise you can test yourself also by expanding summation of qx, and then by applying the geometrical distribution summation formula for infinite series. Now as we are dealing with q in this case, so we differentiate both sides with respect to q, then our term is like this, and after simplification our term is like this, because it is x to the power minus 1. If you separate it, it is q to the power x and q to the power minus 1, and it is inverse of q, so you write 1 by q. Q is also constant, you take it on the side, so that it is q by 1 minus q square equal to summation of x qx. But our objective is not fulfilled. Why? Because in expectation of x square we require x square term, but until now we have got only up to term x to the power only 1, but we require here x to the power 2. So what we do actually, we again differentiate this function with respect to q. So in this case you may practice yourself from calculus also, the quotient rule. If you apply quotient rule here, then summation of x square q x minus 1, after differentiating this equation, you will have term like this, 1 by q over 1 minus q to the power q. And by using all these three equations, because we require expectation of x square, we already have now that sort of thing, and then expectation of x whole square is 1 by p, so we write 1 by p square. So use all these equations 1, 2 and 3. So expectation of x square means it is you have to check here, expectation of x square means we have x square p times of summation x square q x minus 1, but we worked for this summation thing only, so p times of summation thing is here already now, 1 plus q by 1 minus q to the power q. So put all these values, and in place of ex we have 1 by p, so we square it according to this formula and then derive it, then finally we will have q by p square. Therefore you can see that expectation of x equals to 1 by p and variance of x equals to. There are few examples that makes use of geometric distribution, and it will be helpful in your Cambridge examinations. So these are the problems about geometric distribution. You can see that it's already solved for you. So on average 1 in 20, that means probability value is already giving here. So it is on average 1 in 20 members of the population of this country has a particular DNA feature. Members of the population are selected at random until one is found who has this feature. To find the probability that the first person to have this feature is the sixth person selected. So as you know the formula now, that q x minus 1 p, so in place of x there is 6, and probability of success is given as 1 by 20, so it is 1 by 20. Make it 1 by 20. This is not 1 by 2, this is 1 by 20, and q is 1 minus 1 by 20 is this, and then you apply the formula and your answer is like this. And another question states that not among the first 10 people, that means it is talking of only not and not and not up to 10. So all not means all q's. How many q's? Then there are 10 q's, so q to the power 10, and just put the value of q over there to the power 10, and then that is the required probability. Third, it is asking you to find the expected number of people selected. So you know that expectation of x is in geometric distribution is 1 by p. So 1 by p value is here 1 by 20. So we write here 1 by 1 by 20. And similarly, if it will ask you to find the variance, you can also find the variance by using q by p squared formula. And the standard deviation, just take the square root of variance. That will be the standard deviation. Now you can have look yourself in this question. Here in B part, you can see that p less than 8 means 1 minus pt greater equals to 8. That means pt is greater than 7. So you can see that if anything greater than x given, so you can write here q to the power x, not p to the power x, and your calculation will be easy. Otherwise, what you have to do actually, p less than 8 means you have to write pt is less than 8 means you have to write pt equal to 1, pt equal to 2, pt equal to 3 up to 7, and it requires a lot of time. So this is wise to use this sort of technique. Let's go to another problem. Yes, this is et, that means expectation of t. Just apply the formula and then you get that value. Can you stop by here or pause it here and then you try yourself? Let me explain to you what to do for this. Henry makes repeated attempts to light his gas fire. He makes the modeling assumption that the probability that the fire will light on any attempt is 1 by 3. So take this 1 by 3 as probability of success. Let x be the number of attempts at lighting the fire up to and including the successful attempt. Name the distribution of x, stating a further modeling assumption needed. So what is this distribution? The case obviously said that this is geometric distribution, and then write the condition of geometric distribution that applies here. That will answer your question number 5.1. Now in the another part of this question, in the rest of this question, you should use the distribution named in part 1. So definitely you have named that distribution as geometric distribution with parametric value p equal to 1 by 3. Then you should be able to find the probability of px is 4, px is less than 4. That means you require 3 steps here. If you make it 1 minus px is greater than 3, then it can be done in only one step. State the value of ex is easy. Just get the reciprocal of probability value. That will give you the expectation of x. Now Henry has to light the fire once a day, stating on March 1st. Calculate the probability that the first day on which fewer than 4 attempts are needed to light the fire in March 3rd. In this case, from B, from 2, B, yes. Same thing you can take it here. So that probability, according to this question, is the p value. Now you define another random variable that follows geometric distribution with the p value now 0.74 according to this statement. How is it? Pause it here, think, and try to figure out. Now at last it is asking you to find y equal to 3. Just apply the formula and then you get the value of the probability. Now in 6 also, a random variable x has the distribution geo 1 by 5, that means parametric value p is 1 by 5 given here. Then you just apply the formula for ex and get the value of the mean, and similarly use the situation that you have done in previous sums, and then you will be able to do all these part of this question. So while watching this class video, you should pause it here and then try these three sums under the question number 6.1. Question number 2, a random variable y has a distribution. Now it is p. That means parametric value is not open now, and q equals to definitely it is 1 minus p. Now, so that y is odd is this and this. Y is odd means what you have to show here in the infinite series, that first success at the first trial, then at the not second but on the third trial, then on the fifth trial. So you have to take all the odd numbers at which the success happened, and then you add them together just simply by applying the formula. You have this sort of term, and this is proved. The question states that use the formula for the sum to infinity of geometric progression to show that y odd is 1 by 1 plus q. So here you define the first term and the common ratio if the ratio is common. So first term here you can see that this is p, and the common ratio is second by first or third by second, and so on. So in each case you can see that the common ratio r value is q square, and as q is less than 1, therefore q square is also far less than 1. Therefore sum of infinite geometric sequence formula is appropriate here. So that formula states that first term by 1 minus common ratio. So in place of a you put the first term and the common ratio value, and then your result is followed here, and hence this is proved. Now there is another question. You can see, spend few moments on this question. Okay, then drop your doubt if you haven't understood this question number 7 in the comment box. I'll get back to you. Question 8, you can have a look at here, or you can pause it here as much you require the time in order to deal with this sort of problems. Better you explain yourself now, or if any question, you can drop your question in the comment box. So these were some of the examples, some of the questions that relate CAIE A level mathematics questions. You might also be interested to see that how it is px bigger than r is how it is q to the power r. So let's see here now that px bigger than r equals to 1 minus p x is less or equals to r. Let's deal with some examples like px is bigger than 3 means it is 1 minus px is less or equals to 3. And for example, suppose that x follows geometric distribution with parametric value 1 by 6, for example. So in that case, your p value is 1 by 6 and q value is 5 by 6 here. So start from here again, so that it is 1 minus, that means it is px is equal to 1 plus px equals to 2 up to 3 plus px equals to 3. So now use this formula, q x minus 1 or r minus 1, x minus 1 p, so it is 1 minus, you can check if you can get this value directly. So px is greater than r is now q to the power r. So if you are interested to find, px is here greater than 3 in this case. So q value is, so we have q value as 5 by 6 here, so you can write here 5 by 6, and to the power r means it is 3, so it is 3. So here also you can see that 5 times 5 times 5 is 125, and 6 times 6 times 6 is 216. You can check in calculator. So both ways we have got the same answer, but which one will you prefer? Although this also gives you the full marks when you solve this way in your examination, but this is wise to go through this shortcut method, that saves you a lot of time. Okay guys, so this is all for now, and this is all about the geometric distribution, and I hope you will do past papers questions as well as some important questions from your miscellaneous related miscellaneous exercise. So that is all for now, and thank you for your patience.